Hello guys, welcome back to a brand new video. Today we're going to be learning about the weather in junior cycle geography. So let's begin. Weather is a fascinating and ever-changing aspect of our environment. Understanding weather patterns and how they affect our lives is essential for everyone. This presentation will guide you through the fundamental concepts of weather, climate, and related phenomena, providing you with a solid foundation for your exploration of the junior cycle curriculum. So let's begin. Introduction to weather and its climate. Weather. Weather refers to the short-term atmospheric conditions at a specific time and location. It includes elements like temperature, precipitation, wind, humidity, and cloud cover. Weather can change rapidly, sometimes within minutes or hours. Climate. Climate, on the other hand, represents the long-term average weather patterns in a particular region. It is determined by analyzing weather data over decades or even centuries. Climate helps us understand typical weather conditions and patterns over extended periods. The atmosphere. The Earth's atmosphere is a blanket of gases that surrounds the planet. It plays a crucial role in weather and climate by absorbing and reflecting sunlight, regulating temperature, and transporting moisture and heat. The water cycle. 1. Evaporation. Evaporation is the process where liquid water transforms into water vapor and rises into the atmosphere. This happens when water is heated by the sun, increasing the energy of water molecules, allowing them to escape into the air. 2. Condensation. Condensation is the opposite of evaporation. As water vapor rises and cools, it transforms back into liquid water. Droplets forming clouds. The processes occur when the air becomes saturated with water vapor. 3. Precipitation. Precipitation refers to any forms of water that falls from the clouds to the Earth's surface. This includes rain, snow, sleet, and hail. Precipitation is a crucial component of the water cycle, replenishing water sources and providing moisture for plants. Collection. As precipitation falls, it collects in various forms, including lakes, rivers, oceans, and underground aquifers. This collected water can then evaporate again, continuing the water cycle. This process of collection and evaporation ensures a continuous flow of water through the Earth. Temperature and its measurement. Measuring temperature. Temperature is measured using a thermometer, a device that converts temperature into a measurable quantity. Thermometers use various methods, including the expansion and contraction of liquids like mercury or alcohol, to indicate temperature change. Temperature units. Temperature is commonly measured in degrees Celsius or degrees Fahrenheit. The Celsius scale is used in most countries, while Fahrenheit is primarily used in the United States. Temperature variations. Temperature varies significantly across the Earth's surface. Factors like latitude, altitude, proximity to water bodies, and seasons all influence temperature. Higher altitudes and latitudes generally have colder temperatures, while areas closer to the equator tend to have warmer. Frozen precipitation falls to the ground as solid. Precipitation and its types. 1. Rain. Rain is the most common form of precipitation, consisting of liquid water droplets falling from clouds. It is a crucial source of fresh water for plants, animals, and human activities. 2. Snow. Snow is a precipitation in the form of frozen water crystals. It forms when water vapor in the atmosphere freezes at a temperature below freezing point. Snow is a significant source of fresh water, especially in mountainous regions. 3. Sleet. Sleet is a precipitation consisting of small ice petals. It forms when rain freezes as it falls through a layer of cold air near the ground. 4. Hail. Hail is precipitation in the form of balls or lumps of ice. It forms when strong updrafts in the thunderstorms carry water droplets high into the atmosphere. When they freeze and accumulate layers of ice. Wind and air pressure. 1. Air pressure. Air pressure is the weight of atmosphere pressing down on a surface. Higher air pressure indicates a denser and heavier air mass, while low air pressure suggests a lighter air mass. Wind formation is created. Wind is created by differences in air pressure. Air moves from areas of high pressure to areas of low pressure, creating the wind that we feel. 3. Wind direction. Wind direction is determined by the direction from which the wind is blowing. For example, a wind blowing from the west is called a westerly wind. Weather forecasting. Satellite data. Weather satellites provide a wide-angle view of weather patterns, capturing images of clouds, storms, and other atmospheric phenomena. This data helps meteorologists understand the movement and development of weather systems. Radar data. Weather radar uses radio waves to detect precipitation, including rain, snow, and hail. This data helps meteorologists track the location, intensity, and movement of storms. Surface observations. Ground-based weather stations collect data on temperature, humidity, wind speed, and direction and precipitation. This data is essential for providing accurate and localized weather forecasts. Computer models. Computer models use complex mathematical equations to simulate weather patterns. These models incorporate data from satellites, radar, and surface observations to predict future weather conditions. Extreme weather events. Hurricanes. Powerful storms that form over warm ocean waters, characterized by strong winds, heavy rain, and storm surges. Impacts. Flooding, coastal erosion, structural damage, power outages. Tornadoes. Violent rotating columns of air that extends from thunderstorms to the ground, characterized by high winds and destructive power. Property damage, injuries, fatalities, power outages. Floods. Excess water inundating normally dry land caused by heavy rainfall, overflowing rivers, or storm surges. Property damage, displacement of people, contamination of water sources. Drought. Periods of abnormally low rainfall leading to water shortages, crop failures, and wildfires, water scarcity, food shortages, economic losses, ecosystems, and disruption. Heat waves, extended periods of abnormally high temperatures exceeding typical seasonal norms. Heat strokes, dehydration, air quality issues, increased energy demand. Climate change and its impact. 1. Melting glaciers. Climate change is causing glaciers and ice sheets to melt at an accelerated rate, contributing to rising sea levels and impacting water resources. Rising sea levels. As glaciers and ice sheets melt, the volume of water in the oceans increases, leading to rising sea levels and threatening coastal communities. Climate change is intensifying extreme weather events such as hurricanes, droughts, heat waves, and floods, leading to significant economic and environmental damage. Careers in meteorology. Forecasting. Meteorologists use their knowledge of atmospheric science to predict future weather conditions. They work in various settings, including television stations, government agencies, and private companies. Research. Meteorologists conduct research on weather patterns, climate change, and related phenomena. They work in academic institutions, research centers, and government laboratories. Aviation. Aviation meteorologists specialize in weather forecasting for aviation. They provide pilots and air traffic controllers with vital weather information to ensure safe and efficient air travel. And yeah, that's the end of the video. Thank you guys for watching. Make sure you like and subscribe. And make sure you check out our channel for more videos like this. And I'll see you guys next time.